So here I'll be talking about deep learning. Uh, so first, what is deep learning? Well, basically, deep learning, they are the people back in the time, they wrote papers or publications on how the brain works. And then there were other scientists that thought that, oh, this is possible to, if we imitate these architectures that we have in the brain, then we can come up with maybe with nice solutions to many problems. So some scientists back in the 1970s and 80s, they came up with these type of architectures and they wrote them down, but we did not have the sufficient technology to run that. So, for example, we had some very simple networks, and we tried to train it to solve a very simple task, but it couldn't because the hardware we had back then was very weak and couldn't do anything, nothing, not even machine learning, let alone a deep learning algorithm. So in short answers, deep learning means using a neural network with several layers of nodes between input and output, and then we have a series of layers between input and output to do feature identification and processing in series of stages, just as our brain seems to do this. So basically, this is how a neural network looks like. We have an input layer in the beginning, which this is where we feed the data. We have a hidden layer, and then we have an output layer. I will talk about this a little bit later. This is a single hidden layer, as you can see, and then here we have a different model that has multiple hidden layers. So the difference between before and now is basically they can run this model, and this model is obviously not very efficient because it's very small, and our brain has like millions and millions, billions of networks inside. So imagine this is very inefficient, and this is also not as efficient as a human brain, but it can solve some tasks, and that's the difference between back then and now. So first I will give a small talk about the perceptron, which was the first thing that was developed in computer science in the deep learning part. The perceptron came first, and then we had today's algorithms such as convolutional neural networks and other types of networks. So we have a perceptron that basically looks like this. We have the input here. We have the weights, which are the edges to this circle. The circle basically shows a function that actually makes a decision here. So in this case, we will just be using multiplication and an addition between the two. So for example, we have x1, x2, x3, with w1, w2, w3. And then this function, what basically this does is it will multiply x1 with w1, and then plus x2, w2, and then plus x3, w3. So at the end, as you can tell, we will have a number. And that number, will be compared to the threshold, which is the last edge here. And then we will have an output. Basically, an output is a yes or no, or a true or false in this case. So let's have a small example. So let's say we are trying to make a decision to either go to this festival that we have out there. We heard that there was a festival, and we want to know if you want to know if you want to go there or you don't want to go there. So you have three questions you want to ask yourself. Usually, is the weather good? Does your boyfriend or girlfriend want to accompany you? Is the festival near a public transit? So these are three questions. And then let's represent these questions, this one as x1, this is as x2, and this is as x3. And they can be either true or false, so 1 or 0. And then the weights, let's say we will give a higher weight for this question, and then a lower weight for the two other questions. So basically we will have, for question 1, we have a weight of 6, and then a weight of 2, and 2 for both question 2 and question 3. So now if we do the same thing we did before here, so as I said, just like we did before, we have here the equation that represents our decision making, the plus and multiplication and addition function, and then we have these parameters. So we have x1, which is 1, means that the weather is good. x2 is 0, means your boyfriend or girlfriend doesn't want to go with you. And x3 is 0, that means the festival is not close to you. So as you can see that both these questions answer to false, except this question answer to true. And then you have weight. So this weight, we use it as to say that this question is more important than the other. So if, for example, we're giving a weight of 6 to this weather question, and we're giving a weight of 2 to both question 2 and 3. and then we have finally a threshold which tell us like, oh, should final result, should we go or should we not go. So let's make the multiplication that we showed before. So basically we have x1 multiplied by w1, weight 1. So we have 1 multiplied by 6 plus 0 multiplied by 2 plus 0 multiplied by 2. So in the end we will have a 6 value, and since 6 is bigger than 5, then the result should be go. Yes. And now if, let's say, we change this to 0, 1, 1, now if we multiply 0 to 6, 1 to 2 plus 1 to 2, then we will have 4, and 4 is smaller than 5, then that means we don't go. And as you can see here, that this question is way too, the weight of this question is way too heavy, and it's actually heavy enough for both these questions to not matter. So in this case, it's just an example, so it doesn't really matter. But if you want to, like for example, let's say we build a much more complex network of perceptrons, and then here we can make like high decision-making system. So basically, this is how a network of perceptron works. This is the beginning of deep learning. I'm not going to talk about much about deep learning. Like I did, this is not how a deep learning algorithm trains. But if you want to learn more, then you can look up some very nice tutorials that are out there, and just search the term deep learning tutorial, and you'll find out by yourself. So